Hello, everybody. Welcome to today's live session for computer science. Just a couple of house cleaning items ahead of time. Again, our live session calendar was changed from what it originally was, and I posted that last week, or maybe it was early this week, in the announcements, and I also put it in the section of the website, the menu that is dedicated to our live session calendar. So we're going to meet on what is it, Mondays in the morning and Thursdays 1 o'clock. I'll just double check that just to make sure I'm not leading you astray. It is Mondays at 10 a.m. and Thursdays at 1 p.m. So staggered days, staggered times, just in case we have some of you who are working full time, or some of you are part-time students and have classes in the morning and or afternoon. So hopefully that lends you enough flexibility that you can attend one of these at least once a week. Additionally, I do record them all, and I put them in the appropriate content areas of the course. So it's always nice to see students and talk to them, and I enjoy it, and hopefully you get something out of these live sessions as well. I'm probably going to try and make them a little shorter. I have a tendency to kind of dwell on things and likely say more than I need to say about it. So I'll try to keep them a little shorter, and leave a little bit more open time for students to let me know if they're struggling with an assignment, or if they're not sure about how to complete something, or a concept's a little unclear, and that probably be a better use of our time. But we'll continue to monitor it and do what we need to do moving forward to make sure you get the support that you need. So that should take care of kind of live session things. With regard to assignments being handed in so far, pleasantly not surprised, but I'm impressed and quite happy with the majority of the students. The majority of you are handing things in more or less according to the course calendar and emailing me if you've got questions. And I've also had several students, probably more than half, take feedback that I've given them on an assignment where they didn't get full marks and fix it and hand it back in and get full marks. And that's great. That's what the feedback's for, is to help you improve your skills. So for those of you who are handing your assignments in on time and using your time wisely, spending hour and a half, 2 hours on this every day, as is expected. It's one of the requirements for online learning. You should be logging in every day. You should be working for an hour and a half to 2 hours every day. And if you are doing that, you shouldn't have any trouble keeping up. And if you're not doing that, that decision is probably going to not work in your favor with regard to earning a credit in the course. I'm here to help. So I'm only an email away, and we have these live sessions. So if you are struggling, please reach out to me and let me know. It's not like a regular classroom where I can kind of look over your shoulder and instantly tell if you're getting it or not. You're going to need to reach out if you feel like you're struggling with things. So that being said, I do unfortunately have some students that have not been engaging, or clearly have not been spending enough time learning from the materials, or watching the videos, or attempting the assignments, because I can tell that some of the assignments have been very poorly done, or just not handed in at all. I'm going to send out some emails tomorrow to parents and guardians, and just let them know that the deadlines are not being met, and that the student is really struggling, and things need to change. So if you are one of those students who maybe hasn't handed things in on a regular basis and has not been putting in the 1 to 2 hours per day for this course, you might want to take care of that right away before those emails and or phone calls go out. But again, it's a very small minority. And for those students who aren't doing it, if you're not doing it because you're having some trouble understanding it, despite the fact that you've gone through the materials and done what you're supposed to do and taken care of things on your end, I'm here to help. So send me an email, and we'll figure things out. At the end of the Scratch unit, I did all of the Scratch tutorials and fundamentals of Scratch, things you need to know for those first those big Scratch assignments. So I'm pretty comfortable that you've got enough training and information at your disposal to complete those. And several people have finished the Scratch unit and handed in even the big projects, and everything I've looked at so far looks really good. So as long as you're reading the assignments carefully and using the learning materials, people seem to be moving along nicely. Our third unit of the course, our third module, is one where we're going to move from a very highly visual environment to something that's kind of half and half, where you've got half visual environment, and you can see characters moving and making decisions on the screen. And then on the other half, you're getting a bit more into typed in code as opposed to just dragging and dropping code blocks in. And that's going to help us make the transition from a highly visual drag and drop environment. At the end, we want to be in a Python. We're going to be working in Python, a lot of command line and mostly typed comments and mostly data manipulation and decision making, but it's going to be mostly syntax. So keywords and typed in code as opposed to the drag and drop and visual feedback environment. So this is like Reeborg the robot is what I've selected as being kind of the middle ground between the two. The program works very well. I've been using it for, I don't know, 4 or 5 years now. And it's relatively local. Somebody in Canada, I believe, made our implementation of Reeborg the robot. And it's built on top of the Python language, which means that all of the coding that we're going to do will the vast majority will be something that we can take to the Python unit. So when you start the Python unit, you already have, like a good, say 50% of the skills and code and context that you need to do well in the Python unit. It's not like you're going to a completely different language. They're very, very interconnected. But Reeborg the robot, this middle program is it's Python, but it's built in a way so that it's been simplified quite a bit just to help ease you into the coding process. So I find that it's a very good middle ground between a highly visual environment and something that's very syntax based. So what I'm going to do today is I'm just going to give a brief overview of Reeborg and the website that we're going to use and how to A, code, B, save, D, download, and D, upload to your assignments so that I can give you feedback. And it's a pretty simple process. And once you do it once, you'll be fine for the next for the next 6 or 7 assignments. You'll be fine. So I'm going to share my screen. And right now, what you're going to see is the computer science website, essentially. And mine might look a little different than yours just because I've got some menu items that I've hidden from you just to try and keep things simple. But as usual, we're in the learning modules section and we're starting in the Reeborg the robot unit. And as with all the programming that we have done and will do, we're going to keep those 5 major programming principles or the main pieces of any programming language. We're going to keep those always in the front of our mind, where we're going to have input and output, so ways to put things, put information into the computer and then get information back. We're going to talk about data types and storing data, so using variables and storing numbers and names and things like that. We're going to deal a lot with decision-making processes, so if then, if else, those kinds of statements, so that we can make our program go in multiple routes depending on what we need to accomplish. 4, we're gonna do a lot of looping. There's a lot of looping and decision making in this particular section. It's a lot of problem solving, critical thinking, and trial and error, so that you can figure out how to build your logic in a way that works and works efficiently. So lots of looping, repeating actions. And then number 5 is functions, which are essentially little micro programs that you create so that you don't have to cut and paste big chunks of code every time you need to do something. And in fact, the way that this entire, if you want to call it a language or program, works is that they have built a bunch of functions for you so that you can just use them. You will be able to build your own and you will be required to build your own. But a lot of the things that are happening on the screen with regard to visual elements and how your character moves and how it looks on the screen, a lot of that is functions that have sort of been pre-made for you so that you can use them and you don't have to go all the way down to the bottom level to program yourself. And remember from our history assignment, that's known as abstraction. So in this middle unit on Reeborg the robot, it was built in a way that abstracts you from the lower levels of Python code, so it doesn't overwhelm you. So the person that made the program has done all the lower level programming for you, so that you can use the middle level programming to get the output and essentially the solution to the problem that you desire. So it's meant to be a little less intimidating by abstracting you from the lower levels of details. And remember, abstraction in its sort of a general real world sense means that you are distanced from the very low level technical details and processes, so that you can still accomplish a goal using the technology without having to understand every single layer of the technology. And the example I always use is for a car. I mean, most people can drive a car, but that doesn't mean that they need to necessarily understand how a transmission works, or how to build the transmission, or how to fix a transmission, or an engine, or anything down the road. A driver has been abstracted from those things so that they can use the technology and do, probably basic fixes and things with technology, like putting air in the tires and putting gas in the car. But they're abstracted from all those really low level details, so that they can take advantage of the car's main feature and function, which is to get people from point A to point B. So in a similar sense, Reeborg and the programming within Reeborg is intended to abstract you a bit from the lower levels of Python code. And we will get to those lower levels of Python code, but we're going to ease into it with Reeborg instead of just jumping right in. So this is unit 3, and here's the important processes. And if you basically follow me in this video and follow what I'm doing, you'll be able to jump right in and just go and start building things. So there is an introduction to Reeborg the robot, and what I'm going to do, or what I have done, is a good friend of mine who's an excellent computer science teacher at Walter Murray has put together a digital open source web textbook, and it's got things on Python, it's got things on Reeborg, and I believe JavaScript and HTML. Now, we're not going to use every piece of it, but there's no sense in me recreating the wheel. He's got an excellent section of that textbook that's related to introducing Reeborg and kind of easing you into the programming. It doesn't solve the problems that you're asked to solve in Reeborg, but it shows you how you can go about putting the pieces together to solve those problems. So that's always going to be your primary resource, is that digital textbook. And it's available at opensask.ca. This is all linked to within our class. But if I open up the OpenSask.ca website, it looks like this. And I've actually got it going directly to the beginning of the Reeborg section, but his entire website, and it's really just a website that acts like a textbook, is right here at opensask.ca. So you see there's a big Scratch unit here, and then there's a Reeborg unit. Now, we've already done Scratch, and I used, I think a few of these, but not many. But we're going to focus heavily in this Reeborg area, and then I've got my own materials for Python. So we're really just going to use this chunk for Reeborg here. And the way it's going to work is that when we're in our classroom, back up one step here, when we're in our digital classroom, each step of the way, so these first two are basically just to get you to the textbook, you're going to have assignments, and they're going to be grouped, because most of them are smaller assignments. There's 20. There's 20 of these programs that you have to build, and I separated them out into 5 assignments, I believe, maybe 4. So Reeborg's organized in steps. And if I show you, there's links here, but this is what the Reeborg world looks like, where you have a character, Reeborg the robot, and you have a goal. And in this case, the goal is very simple. You have to move Reeborg using code to the house, and then you either did it correctly or you did it incorrectly. So if let's just go in here, you have certain commands that you can just type in, and you are going to have to type things in here, but there's a reference and there's a library of things that are pre-built in. Okay, those are those functions that the developer of this program built for you, so that you don't have to understand the lower levels of code. You can just use it. You are going to build your own functions, but we kind of ease into it. So there's already a way to move. Reeborg built in, and you don't have to program the lower levels. All you have to do is type things in the correct context. And when I say context, or syntax is a better word, I just mean you have to spell things right. You have to have capitalization properly. Your capitalization has to match the program, and all your punctuation and things like that, characters. Computers don't guess. They do exactly what you ask them to do. And if you misspell something, or if you have a capital letter where it shouldn't be or whatnot, it just breaks your program. So if you're one of those people that has a little difficulty with those minor details, you're going to want to pay very close attention, because those little details that might not mean much to you if you spelled the word move wrong or something like that. In the real world, it probably wouldn't matter all that much, but it'll completely break your program right away. So you have to be very, very careful about your syntax. So there's something called Reeborg's Keyboard, and these are all the built-in functions and processes that you don't have to recreate. but it's like a library that you can grab things from. You can click on them and they'll go in your program, or you can just type them out the way that it's spelled out here, and it'll go there too. So for instance, there's commands, conditions, general Python things. You don't have to use too many. If yeah, you have to use a couple of these, but not too many from this section. Objects, you don't have to use this tab at all, and special, you don't have to use that. So basically, you're looking at commands and conditions are the ones that are built in that you're actually going to use. And it doesn't look like there's many of them, but you can make some amazing, you can solve some amazingly difficult problems, logic problems, using just these sort of basic features. We're going to create our own to make our life easier, but we have a starting point. So for instance, in commands, you'll notice that the first one is move. Reeborg always moves in the direction in which they're pointing. So if I say he or she or whatnot, please just excuse me. I don't know the robot's gender, but sometimes I say he and instead of they or whatnot, and I'm doing my best to address that. In any case, Reeborg is facing a certain direction, and they will continue to move in that direction until you tell Reeborg to move in a different direction and proceed. So there's a move right here. So if I just click move, you'll notice that it puts it right into your code for you. But you don't need to do that, and you will memorize most of these commands really quickly because you'll be using them a lot. So if I want to move twice, I could go back and click the move thing again, but I would just type in move again. And you have to make sure that you got these two brackets at the end, and everything is looks exactly right it looks exactly the same as it would in this keyboard or reference area. If you spell something wrong, or if you capitalize something where it shouldn't be capitalized, you're going to notice that your program breaks. So I'll actually imitate that in a second and give you an example. So the only code I have here in the Python code section, we'll ignore the library for now, is move, and then I've got move again. So Reeborg is going to move twice. When I click the play button over here, Reeborg 1, 2 moves twice, and then I get an error warning pop-up. And sometimes these pop-ups are good because they tell you did it properly, and sometimes it tells you that things didn't go the way it should have. So right now, my program didn't break. It ran from the start to the end, but it says Reeborg is in the wrong X position. Reeborg is in the correct XY position. So all this does is it checks where Reeborg is at the end of the program, and if Reeborg's in the right spot, it'll give you, 2 green messages, and then you're good. You've got the program completed. You can download it and then submit it for your, as one of your assignments, and that's great. If you've done something wrong, you'll get a message, but it won't tell you exactly what's wrong most of the time. Most of the time, it'll just say Reeborg's not where Reeborg needs to be. Our XY coordinates work exactly the same way as they do in Scratch. The X's are dealing with horizontal, just like in math and Cartesian coordinate system. Y's are dealing with up and down. In this particular world, because there's a bunch of different worlds, there is only one Y value because Reeborg can only move left to right. There's no place that Reeborg can go up and down. So even by default, if you did nothing, you were on the right Y position, but you're not on the right X position because Reeborg only moved 2 steps, and Reeborg needed to move all the way over to the house in order for things to be correct. So you just cancel that message, and then you keep building onto your code. Now, I know I need to move 2 more times. So let's move once. But let's say I make a mistake and I accidentally put a capital M instead of a small m. This right here resets your program. So I tried, it didn't work. I reload it, and now you notice Reeborg's back to the starting location. It didn't do anything with my code. It didn't delete anything. It just resets this visual environment. Now when I press play, I get an instantly undefined. The name move is not defined. And it's true. The command move is with a small m, but I tried to put a big M. So right away, it broke my program instantly. It was a tiny error. And like I say, in the real world, that wouldn't have made much of a difference. If I capitalized something in an essay that should have been capitalized, it's not going to prevent you from reading to the end of my essay. However, in a computer program, it stops right away and breaks it right away. So if I change that to another lowercase m, now things look proper. I will stop my program, reload it, try again. And look at that. With 4 moves, I got to the end of the program, and now the message I receive is Reeborg's at the correct position. You've successfully completed this program. And what you're going to notice up here, this is the navigation between all of the worlds. And it's linear. You're going to start at 1, go to 2, go to 3, go to 4. But you'll notice that there's a check mark now there. And that's just a reminder for you that, hey, you've done one, you've done it correctly, and it's checked off. So when I open up my drop down, you'll notice there's checks for just about everything because I have completed all of these at points in the past, including these ones. But probably not in this browser. So you won't have all those check marks right away. But every time you complete something, it'll give you a check mark. And all you need to do at that point is you need to move to the next step, which is another world and another problem. Every time you open up a new world and move on to the next Reeborg program, you need to go to the world info button and click that, because this tells you exactly what commands you need to use and exactly what the problem is. It doesn't tell you how to solve it, but it tells you what you need to include with regard to programming commands in order to complete the process. So for number 2, it says it's weeding time. Okay, we want Reeborg to pick up the dandelions and then put them in the garbage and return home. So it tells you everything you need to know. These green ones with the red number 1 are the dandelions you need to pick up. This grayed out space is where you need to, basically it's a garbage can, you need to dump out whatever you picked up. And then you need to go to the home, which is over here. So you don't, when it says return to home, it's assuming you already left and you're over here. You don't have to go to this end and then go back to where you started from. You just need to pick dandelions, dump them off, and then move to the home. So there's a couple new nuances in here that we didn't have before. Now we still need to move to get from the left side of the screen to the right side of the screen, but we also have to do things like picking up dandelions, and then we have to do things like dumping dandelions. But it's a relatively simple process. And it says, this is what you need to know. You need to know how to use the move command, you need to know how to use the put command, and you need to know how to use the take command. So unless you have used all of these items, you won't receive full marks. Even if you manage to get Reeborg to the end, every time it says what you need to know in an assignment, in a world, you need to include all of those things. Otherwise you will lose marks. So every time you go to a new step, click on the world info button and make sure that you are that you're using all the commands and processes you need to use. And it also tells you where your final goal is. You must be at 6, 1. So this is the 6 on the X, and then it's the only 1 on the Y. So 6 and 1. Basically, find the house. It's always a house or a checkered flag is always what you're looking for. And sometimes you drop an item and you start, and the program's over when you get back to the item. But aside from that, it's house and checkered flag. So that's the end of each program. So once you know what you need in order to solve the problem and make Reeborg do what Reeborg's supposed to do, you can just go back and start coding again. So I'm going to move, which is going to get me on top of the first dandelion, and then you could check in the Reeborg keyboard, but I already saw from the world info that the command for taking something is take. So I'm going to move. I'm going to take a dandelion, and it just puts it basically in a virtual bag. So there's an inventory, a list that Reeborg you don't see, but Reeborg remembers. So if you pick up 3 dandelions, the program remembers that you've got 3 dandelions in this sort of handbag or garbage bag or whatever you want that Reeborg's carrying. So I know I need to move, take a dandelion, then I need to move again to get to the next dandelion, and then I need to take another dandelion. Then I know I need to move again, and then I think I got to take a 3rd dandelion, then I got to move again, and then always just, like this program's really simple, but typically what you're going to do is you're going to complete a portion of it and then just see where you are and build from there. This program's easy, but once you get to some of the later programs, there's no way you're just going to be able to code it at once and have it be right. You're going to have to test it and change it and test it. So the best way that you can test something, I'll just show you the quick way, is if you're going to test your code, what I often do is I just start out with this step button instead of pressing play. If you press play, Reeborg will do what you ask Reeborg to do, and it will do it one step at a time. And it'll just go to the end where either you're done your code or Reeborg makes a mistake and hits a wall or something like that. But oftentimes, just because I want to test it quickly, what I will do is I will click the step, and then there's this little slider. And then I'll use that to skip to certain places of my code. So you notice as I drag this slider around, it moves through my code quickly. So if I know that the first 25 lines of my code are fine, and then it's between line 30 and 35 that I'm having a little trouble, I'll just skip to that part and then work in there and fix it. Also, if I'm testing it and I think I've got it right, so let's just say I'm going to finish this program. I picked up 3 dandelions. I need to deposit 3 dandelions. So that command is put. So I'm going to put 3 times, and I know, hey, why are you typing all these things out in a repeated order? Isn't there a better and more efficient way to do that? Yes, there is, but that's part of the learning that we're going to do. So I'll put those 3 dandelions in the garbage. I'll move one more time, and I should be at the house. So I think that I coded this entire program. I think it's right. I could reload and hit the play button and let Reeborg kind of bounce through one step at a time. But if I'm being impatient, or if I know how to use Reeborg and I'm working through assignments and I don't necessarily need to see him take each step and pick up each dandelion, I'll just I'll click on the step button and I'll just kind of do that. Get it right to the end. And you know, as you see, I did things correctly. I got to the final spot, and I for a while you're probably going to want to click the play button just so you can watch Reeborg and watch what Reeborg's doing and how Reeborg picks things up, puts things down. But there will come a point where you'll just be like, okay, I want to test this. I want to test it quickly, so I'm just going to step through and then fast forward to line 9 and then fix my things and then see if it works, kind of deal. So for efficiency's sake, that's usually what I end up doing, but it's certainly okay if you like hitting the play button. If you like hitting the play button, but it's moving a little bit too slow or too quickly for you, there's a think command. And that's basically the amount of time that Reeborg pauses before Reeborg takes the next step. And so if you put a think 0 in, Reeborg basically thinks for 0 time, and Reeborg flies through it. So if I put in a 0, you notice how quickly that happened. I hit the play button, and boom, Reeborg's done. And as you adjust this number, it'll go slower. The higher the number, the slower it goes. So if I put in, I think it's set to milliseconds. So if I put in 100 milliseconds and then hit play, it's still relatively quickly, but it's slower than it was before. If I put in 1,000, that's basically 1 second per move. So now you'll notice Reeborg's moving quite a bit slower. So you can put in the think command to adjust the speed of the program, but I think most of you after a while are probably just going to hit the step button and use the slider to move as quickly or as slowly as possible. It just gives you more flexibility over what you're doing. So that is how you that's how you code. That's how you see your output. That's how you find out what problem you need to solve. That's how you navigate between worlds. And then don't forget, if you're struggling a bit, look at the keyboard, because there's things built into commands and conditions that will help you solve the problem. And if you start out, it starts out relatively easy, but when you get to a point where it's starting to get more challenging and whatnot, there's always a solution, and there's often more than one solution. So there isn't necessarily a one answer, one correct answer kind of deal. There are always multiple different ways of solving a problem. When you've finished your step, you always want to go back to it and see, is there a more efficient way that I could do this? I've got 100 lines of code for this thing, and it just seems like I'm repeating a whole lot of processes. Is there a way that I can build functions or reorganize my code, or fix the way I'm looping things in order to make it work the same way but be more efficient? And usually the answer is yes. So I challenge you, and there's one that actually has a very specific challenge, to not only code it correctly and document it correctly, but to go back after you make it work and see if you can make it work efficiently. And that's what I always do when I'm solving problems like this. I just get it to work once, any way I can, to make sure that I've got a program that's working and solves the problem. And then after that, I go back and see, is there a better way I can do this? So I usually save one copy of the program when I think I've got it done properly. And then I'll copy that code and paste it, and I'll save another version. And the new version is I want to try and make it more efficient. I want to make it faster. There's a better way to do this version. So I will have actually 2 separate files. In case I try to make it more efficient and I end up getting totally confused and screwing things up, I've still got the original one that I know works, even if I suspect it's not the most efficient version. So I'd recommend you do the same. Along those lines, how do you save things? How do you upload things? How do you download things? Okay, so this is you have to hit the reload button here in order to see these. Oops, share my right screen. As soon as you hit the reload button, no matter where you are, you have 2 options up here. One of them is to save your project, and one of them is to upload a project, so open a project. So I've made a program here. If I'm going to save it, it doesn't work quite the way saving works in some other programs. When you click save, it actually just automatically names it and downloads it to your download folder. So when I click save, you'll notice down here I got this little message, and you might, depending on your security settings, you might get this too. It says, because they're Python files, their extension is .py, and sometimes computers are set up to prevent you from downloading these because .py files could conceivably contain viruses. But I've never actually had a student who couldn't download them, so that's over a lot of years of teaching. So I think you're okay, but you might get this message. This type of file could harm your computer if you want to keep it anyway. And it tells you what the name is, step2 .py. So if you hit keep, all it did is it put the step to program inside your downloads folder. So let's say I navigate away from Reeborg for the day, and then the next day I come back and my program maybe was only half finished or something like that. I go to my Reeborg website. There's links all through my the module 3 to get to this page, so don't worry about it. Now it did remember it was stored in my browser cache, but let's say it wasn't, or I was working on a different step or something like that. Just make sure that you go to the correct step. So I was working on step 2, so I want to make sure I'm on the step 2 world, because it doesn't always remember where you were. And now I've got nothing in my code area, so I have to actually upload my code. And the way you do that is with the folder. So you just go to the folder, and now this is like any other web process. You go to the folder, you find where you save the file. Yours will have a different icon than mine, but you find where you save the file, you go to open, and then you'll notice the code loaded back up, and it will be the same code that you left. So you can either you run it again, or you can fix it or whatnot and save it again. So that's how you download the code that you've done, and that's how you can re-upload code that you were maybe half finished or you were trying to improve or whatnot. So make sure that you have a folder. In fact, on your computer at home, I strongly recommend you just create a folder for Computer Science 20 and then create a folder inside that for all your Reeborg stuff. So it's always in the same place, and you always store your Reeborg files there. And it's just for an organizational purposes. It makes it easier, because if you're constantly accessing things from your downloads folder, you never know. If you're not the only one who uses the computer, someone might go in there and recycle everything or trash everything or move things around. It's easier if you create, and better if you create yourself a dedicated Computer Science 20 folder that's not in your downloads folder. Maybe it's on your desktop, or maybe it's on some part of your C drive or D drive or whatever. But I recommend you have a dedicated folder for this class, so you've got backups of all your files and whatnot. So I showed you how you can upload files. I showed you how you download files. And the only other thing you really need to do is, when you've completed the programs that are in each assignment, you hand them all in at once. Now, some people like to make a zip folder and put 5, 6 programs inside a zip folder and hand in just the one zip folder instead of handing in 5 different things. I don't care how you do it. It's just as easy either way, I suspect. But this is how you're going to hand things in. So, for instance, let's go down to, one more thing, sorry. How do you learn the skills? How do you learn take and put and whatnot? Those ones are relatively straightforward, but there are ones that you use later on that are significantly more difficult. So you have to have some resource and learn how to do this. Right here where it says 3.3 Reeborg lessons, step 1 and step 5, that's not an assignment. This is actually the learning that you do before you complete each step. So if you're going to complete, let's say, step 3, the expectation is that you go to this section and then you go to step 3, turning left and stepping through code. And what that's going to do is it's going to take you to the website, into the e-textbook, specifically at the section where it tells you and shows you how you step through your code. I did a lot of this in the tutorial, but it's also in the learning materials. Here's how you pause. Here's how you step forward one at a time. Here's how you stop a program. Here's how you reload a program. And here is a visual version of step 3. So this is what you're going to need to do. You're going to need to walk to the corner. You're going to need to turn left. And it basically is what you see in the world info. But most of the time, it gives you more information and tutorials on how to use that specific function. Now, again, these early ones are pretty easy. There isn't a whole lot of explanation. What does turn left do? It turns Reeborg to the left. So, there isn't a whole lot of information in here that's gonna add a lot of that's going to help you out much. But once we start getting to making our own functions and creating more complex logic and loops, you're definitely going to need to go through the learning materials. And some of them have little animated GIFs that show you what's happening, but most of them it's just read and look at the picture and you'll be able to do it. If you are struggling with something in Reeborg, the first question I'm always going to ask is, did you look at the textbook? The early ones you could probably do without even consulting the e-textbook at all, to be honest with you, or figure out on your own or whatnot. But there will come a time where things get significantly more difficult. And if you run into trouble, you really, really need to go and look at the e-textbook, because it does tell you how to do something. It won't necessarily solve the logic problem for you. You're going to need to use critical thinking to do that, but it will give you the commands you need and show you how to do each of those commands, or show you how to use each of those commands. It just won't put them all together in the order that will solve the problem. You are still going to be responsible for that. So that doesn't mean I won't help you, but it does mean that I have an expectation that you will have done the reading that I've asked you to do prior. So if you've gone to the textbook and you've done step 3, the learning or reading or whatever it is, you can go back to the website, and there's links everywhere. And now I'm on step 3. I know how to use the turn left command, so I can really just start coding right away. I need to move. And yes, there's more efficient ways to do this, and we will learn them. We will get to them. So Reeborg moves 4 times. Then Reeborg uses the new turn left command or function that I just learned, and you'll notice there's an underscore there. If you don't have that underscore in, it's not going to work, just like if you forgot a bracket or capitalization. And this, in my mind right now, I said, I think that I've coded enough to get Reeborg to the first corner on the right and then turn and face up, and then I'll move Reeborg one more time. So instead of me coding the whole thing and then testing it at the end and finding out I made a mistake, I just can break it up into chunks. Okay, can I get Reeborg to the corner? Can I turn Reeborg so that he's facing up? And can I move 1 step? Well, I think I did that there, so I'm going to step through it and just check. Yep, exactly. I got the error message because I didn't actually finish the program, but I could see clearly from my progress over here that Reeborg made it to the corner, Reeborg turned, and Reeborg took 1 more step. So I know that I'm in good shape and I can continue moving upwards, doing what I need to do. So I always recommend that you solve it a bit at a time, and make sure you're testing it along the way. And then when you think you've got the program completed, go save it as one file name, and then save it again as a different file name, and then see if you can make it more efficient or faster or however. Okay, so that's the process, right? Go to the textbook, learn about the new skill, whatever it was. In this case, it was turn left. Go finish the step, the actual program. Then when you're done, I think that after that I was done assignment 3 or step 3. It's working properly. Download it, and now the last part is you need to sort of collect these and hand them in as the assignment. And it's quite straightforward. I mean, really, students rarely have difficulty with this. So if I go back to our Blackboard website, this was the learning part. And I have all sorts of videos and stuff in here and tips on how to solve the more difficult steps and whatnot. But ultimately, assignment 6 here is from step 1 to step 5. So you're going to have to hand in 5 Reeborg programs. That all counts as assignment 6. If I go into this assignment, it just looks like any other assignment. It's worth 5 points. This, as they get more difficult, they're worth more marks. But this one's worth 5 points, 1 for each of the 5 steps. Okay, so I said you can make it a zip folder, you can make it a RAR folder. But really, I don't care how you do it. I think probably the easiest way is just to do this. You go to Browse Local Files. Okay, then you go and let's just say these are all, I mean, some of these are scratched, but let's just say these are all Reeborg programs. I'm just going to hold down the Control key. I'm going to click the ones that I want to include. So that would be step 1, step 2, step 3, step 4, step 5. And then what I'm going to do is I'm going to click Open. And you'll see it puts all of those files in at once. And then if I've got step 1, 2, 3, 4, 5 all there, I'm going to hit submit. And what happens there is you get a message saying you handed in these programs at this time. And for this assignment, I get a message saying there's something to be marked there. I can access all 5 of your files. I can put feedback and a mark in and give it back to you. And it's just like really efficient. So that's really all you have to do. When I mark them and hand them back, if you had them all correct and you got 5 out of 5, great, move on to the next one. If you got 4 out of 5, chances are you made one minor mistake on one of them or forgot to include one of them. The feedback will say that. The feedback will say 1 to 4 are great, you missed this on number 5. And then all you need to do, you actually don't even need to hand in all of them again. If you just made a mistake on step 5, fix step 5, download your final version, and then just upload, resubmit the assignment with just just step 5. I don't need to mark the other 4 again. I already know you got those ones correct. So just hand in the part that you needed to fix. That's actually easier for me and it's easier for you. So if you messed up on step 5, but you want to get full marks, and remember, you can resubmit these as many times as you need to. Just resubmit what it is that you lost marks for. That's all you need to do. So you would resubmit, and I would see a thing saying, hey, there's a second attempt, and I would open that up and say, okay, they only handed in step 5 on the resubmission. So I could do a quick double check and see, yeah, that was the one they had wrong. But really, most of the time, you know which one you had wrong. I've told you which one you have wrong. You needed to fix. You hand in just the one you fix. I look at it. Yep, they fixed it. That's great. Now you got 5 out of 5, and move on to the next one. So this can be quite an efficient unit, and I typically mark things really quickly and turn them around really quickly. And if you get it, you can just keep flying. Now, the first ones, again, seemed pretty easy because they were pretty easy. There's going to come a point up around, 13, 14, 15, step 13, 14, 15, where the problem solving is quite a bit more complex, and the use of loops and decision-making structures is really going to challenge your critical thought. So don't get overconfident, I guess. If the first ones seem easy, they are easy, but you are going to get to a point where you're going to have to exercise quite a bit of planning, and it always helps. I find it always helps just to have a little piece of paper there, just a little scratch pad to doodle what you think you need to do with Reeborg and whatnot. And there's a lot of trial and error. I think this structure or this decision making or looping process is going to work. I'm going to try it and see if Reeborg does what I want them to do for the first 10 steps of the program. If Reeborg does, that's great. I'll keep going. If Reeborg doesn't, maybe I'm back to the drawing board and I try again. So don't be afraid to sample and play with it. And what I sort of colloquially refer to as throw stuff at the wall and see what sticks. And that's a perfectly acceptable idea. Hey, in a perfect world, you'd be able to look at the problem and instantly solve it in your head, and then instantly have efficient working code, and then hit play and it works perfectly. That is never ever the case in a real programming circle. There's always going to be errors. There's always going to be ways to make it more efficient. There's always going to be little things that have been done incorrectly. Very, very rarely is any project that's meaningful and not completely trivial completed on the first try. There's always debugging, and you're going to hear that over and over again. There's a mistake, so you got to debug it. You got to find where the error is, and you got to fix it. And usually when you fix it, you find another error. And sometimes sometimes you have 3 errors, and you fix one of those errors, and now you have 7 errors. Okay, welcome to programming. As frustrating as the process can be sometimes, when you finally get the right answer, I assure you that the feeling of pride and success far outweighs the frustration you had getting to that point. Are there any questions about that? It really is quite straightforward. As long as you understand what I was saying in this tutorial, or you just read the instructions there, it should take you through the same process. And I don't think you're going to have much difficulty with it. Most people fly through steps 1 to say 12, and then it takes longer because the programs and problems are bigger. But rarely do people have any difficulty finding the textbook or finding the Reeborg website or how do I download things? How do I upload things? It's usually pretty intuitive, and people take to it rather quickly. Not going to lie to you though, some of those later programs, particularly step 18, 19, 20, they're challenging. They're very challenging, and it's really gonna push you to use your critical thinking skills and logic skills. But it's good because logic is not something that's taught in a whole lot of other classes in high school. But it is extremely important in the real world that you're able to think critically and solve problems using logic and reason. And that's a very valuable skill. So it's something that I'm glad that you're in this class to practice. And you'll find that that skill transfers over quite nicely. So that's a pretty good intro to, well, I don't know if it's good, but it's a reasonably comprehensive introduction to Reeborg the robot. Essentially, it is the middle ground between Scratch and Python. It is built on top of Python. So a lot of the code that you see will be code that you will actually continue to use even in our big Python module, which is Unit 4. And it's still visual in the sense that you can put in input, you can put in code, and you can see what's happening on the screen in front of you to help you solve the problems. So there we go. I did that about as quickly as I could possibly do it. And we're going to be doing Reeborg for the next, I didn't look at the calendar, but probably for the next, 2 weeks minimum. So we're going to be in this section for a while. Are there any questions that I can answer for you right now? First, with regard to Reeborg, and if not, with regard to anything else? Not seeing or hearing any questions, so that's probably a good thing. And that's all I had on tap for today. So if we're comfortable with what you've been doing in Scratch and the planning process, flowcharts, etc., hopefully you've been getting the answers that you. Hopefully, when you ask me a question via email, you're getting a response that helps you solve the problem. And most people have been pretty good about emailing me back and saying, "Hey, thanks, it worked," or whatnot. But definitely, if you're struggling with something, contact me sooner than later. Make sure you use all the resources at your disposal and keep working hard, because the work, by and large, the work I've seen so far from students and what's been handed in has been very good. So I would say stay the course and keep doing what you're doing and try to stick to that course calendar as much as you can. So thanks everybody for coming today, and we'll see you at the next live session.